Now, let's learn how to determine the domain and range. Domain is the values of x for fx axis, while range is the values of y for x axis. So there are two methods to find the domain and range. First, we can use graphical approach. Second, we can use algebraic approach. So let's look at this example. So we have to sketch the graph. We have to identify the domain and range by using graph. So first, we have fx equal to negative 2x plus 4. To sketch the graph, we can substitute x equal to 0, then we get fx equal to 4. From this, we get 1.04. So when we substitute fx is equal to 0, then we'll get x is equal to 2. So we have another point which is 2, 0. So from these two intercepts, so this is the x-intercept, this is the y-intercept, then we plot the point there. So we connect the 2 points, then we get the graph. So from this graph, you can see that the domain of the function is actually no limit. It's from negative infinity to infinity, or all the real number. Same to the range. So the values of y, which is fx, which is x defined, so you can see all over the line. So meaning that from negative infinity to infinity. So we can write that the domain of f is actually all the real number, or you can write as from negative infinity to infinity. Okay, so I write as this, all the real number, or range also all the real number. Or you can write as from negative infinity to infinity. Here also from negative infinity to infinity. So next, you can have a try on this function. Second one, fx equal to 4x minus 1. So you use the same method. You find the x-intercept and y-intercept as this, and then you draw the graph, and then you determine the domain and range by looking at the graph. Next, we have quadratic function graph. So let's look at this graph. So this is the function. So we have y is equal to x minus 3 squared minus 2. So from this function, so we notice that the minimum point of this graph is at 3, negative 2. So this point is 3, negative 2. Okay, so meaning that the range of this graph starts from here, starts from negative 2 and above. So we can write this as the range of f is from negative 2 up to infinity. But for the domain, so no limit. It's from negative infinity to infinity. So we can write the domain of f is all the real number, or you can write as negative infinity up to infinity. So meaning that for quadratic function, to determine the range, you have to determine the minimum or maximum point first, before you can determine the range. Okay, now let's look at this one. So we have fx is equal to 2x squared plus 4x minus 5. Okay, this time, how to determine the minimum or maximum point? Okay, so first we can use completing the square. Okay, how to do the completing the square? First, we have to factorize 2. So when we take out 2, then we get 2 times x squared plus 2x minus 5 over 2. Next, we have to put x squared plus 2x plus 1 in complete form of square. Then we get this. So we have x plus 1 squared, and then minus 1 minus 5 over 2. From there we get negative 7 over 2. So from this we get 2 times multiply 2 into the each term of this in this bracket. So we get 2x plus 1 minus 7. So from this function, so we can determine the minimum point. The minimum point is when x plus 1 equal to 0. So which is equal to x is equal to negative 1 and y is equal to negative 7. So the minimum point is negative 1, 7. So we can put it here. Now you plot the point negative 1, 7 as the minimum point, and then the curve should be opened up because the coefficient of x squared is positive, and then the y-intercept we can take from here, so which is equal to negative 5. So meaning that the graph should pass through this point 0, negative 5. So you connect the 2 points there and going up. And then because you know that for parabola the graph should be symmetry, so you do the same for at the other side. So from there you get the graph. Okay, so from this graph you can write that the domain of f is actually no limit, it's all the real number, while the range of f is equal to negative 7. So negative 7 to infinity. Negative 7 to infinity. Now let's continue with cubic function. So if you are given fx is equal to x squared times 2 minus x. So to draw the graph, you should find the x-intercept first. So to find the x-intercept, so you must let fx is equal to 0. So meaning that when fx is equal to 0, then you will get x squared times 2 minus x is equal to 0. Now you get two values of x, which is x is equal to 0 and another one is x is equal to 2. So you can sketch the graph now. Let's plot the 2 points that we get just now. So we have 0, 0. So this is the point. So this is the point 0, 0. And then next we have 2, 0. So let's say this is 2. So this is 2, 0. Okay, so now how to sketch the graph? Okay, so you must take a few values of x. So how to do that? Okay, so let's say you take 1. So if fx equal to 1, if let's say f1 x equal to 1, then you will get 1 squared and then times 2 minus 1. So which is equal to 1. So you can plot the point 1, 1. So it should be here. Okay, so this is 1, 1. Okay, so next you can take negative 1. So this is 1. Okay, sorry to forget. Okay, so let's say you take negative 1. If you take negative 1, so f negative 1 is equal to negative 1 and then squared and then times 2 negative 1, which is equal to 3. So you can plot 3 there. Negative 1, 3. So let's say this is 3. So you can now imagine the shape of the graph. So if you connect all the 3 points you get 0, 0, 2, 0 and 1, 1, and another one is negative 1, 3, negative 1, 3, 0, 0, 1, 1, 2, 0, then we'll get this graph. So from this graph, what did you notice? So there is no limit for x, no limit also for y. So therefore, you can write f, the domain of f. So you can write the domain of f is, so you get the domain of f. So the domain of f is from negative infinity to infinity, and also the range of f is also from negative infinity to infinity. Okay. If you get this kind of function, fx equal to x cubed plus 27, how can you sketch the graph? Okay, actually you do the same as number 1. So where you have to find the x-intercept when f of x is equal to 0. And then you find a few more points, and then you just connect all the points to get the graph. Okay, let's do it together. If you substitute fx is equal to 0, then you get x cubed plus 27 equal to 0. So you get x is equal to negative 3. So now you have negative 3, 0 as your first point. That is, this is the x-intercept. So next, you notice that we have function x cubed plus 27. This 27 is actually the y-intercept. Now you can plot the y-intercept at 0, 27. So to get the shape of the graph, you have to find a few more points. So let's say you take x is equal to negative 1. So when f is equal to negative 1, then you get x is So when you take x is equal to negative 1, then the fx is equal to 26. It should be up here. Okay, and then another one, you can take negative 4. So f negative 4 is equal to negative 27 down here. So what you can do is you can connect all the 4. Okay, then you can find another point. So let's say you take 1. So f1 is equal to 28. So then the graph is going up. So from this sketching, you notice that the domain of f is all the real number, and the range of f is also all the real number.